Hi everyone, this is a quick video where I'm going to show you how we can use the vertex of a parabola and any other point on that parabola to find the equation of the quadratic function. So the key to this problem is to remember our vertex form. So what I'm going to do is write that down here so we can remember. So our vertex form of a quadratic equation is this. We have f of x equals a, I'm going to put this in red, a times x minus h squared. This is our first part. A times x minus h squared plus k. Alright, so I put a, h, and k in these different colors because if I'm going to figure out the equation, these are what I have to know. I need to know a number to put in for a number to put in for h, and a number to put in for k. So my goal throughout this video is going to be to show how we can use this information up here, this vertex, -1, -3, and this point to find these three values, a, h, and k. Well, since I have the vertex, this is actually incredibly powerful. So it gives me so much information knowing the vertex because this 1, that's my h, and this -3, that's my k. So the vertex, this is always h comma k. Okay, so whenever I have a vertex, that's always going to be of the form h, that's the x coordinate of my vertex, comma k, which is the y coordinate of my vertex. So already I have so much information here, and I know that I can reduce my equation to this here. So I know what h and k are. I don't know what a is yet, but I have x minus, now h is -1, so I'm going to do minus -1 here, squared, plus, now I know what k is. I know k is -3. So I'm going to put a -3 in there. Alright, so now I can clean this up a little bit. I have these negatives that are all over the place. So let's do this and say this is f of x is equal to a. Right, so we still don't know what a is. But x minus -1, that's really x plus 1. So this is x plus 1 squared. And if I'm adding a -3, that's really a -3. Alright, so with my vertex, this is really awesome. I have almost all of the information that I need, except I need to know what a is. So we call this a leading coefficient, and I need to figure out what a is. Well, if I go back to my original question, the information that I was given was the vertex, and we can see that I've made pretty good use of that here. But I haven't used this point yet. Okay, so well, how do I do that? All right, so if I'm given a point on a function, what this is if we recall from our earlier videos about general functions in general, this is an input-output pair. All right, so this point right here, 2, 5, this is really an input, right? So 2 is going to be in my input, and 5 is going to be my output. And so when I'm dealing with quadratic equations, or any equation, any function in general, my input, this is going to be my x value, my output is my y, or sometimes we use this, right? So we use f of x. So input is x, and output is f of x. Okay, so if I think about this, what I can do is I can plug in this 2, 5. So 2, 5 is really x, f of x. And so I can plug in that over here. So I can plug in my 2, 5 for x, f of x. Let's give ourselves a little bit more space here. So x, f of x. Well, so I'm going to give myself a little reminder what that was. So this is 2, 5. So I'm just going to plug this in. And so 5 is equal to, and we still have a, times 2 plus 1 squared minus 3. Okay. 5 is equal to a times 2 plus 1 squared minus 3. Well, if I take a step back and I look at this, notice how everything is a number except for a. A is the only thing that's remaining in this equation. I have a 5, 2, and a 1, and this is squared, and minus 3. So what I can do is I can get all of these numbers together. I can rearrange everything to get a by itself, and that will tell me what the value for a is. All right, so step 1, 5 is equal to, right, we still have our a, but 2 plus 1 is 3, so this is 3 squared minus 3. And so I'm going through my order of operations. So the first thing I do is take care of everything in the parentheses. And now I take care of exponents. So step 2 would be, well, 5 is equal to a, and 3 squared is 9. So this is a times 9 minus 3. All right, so now what I have to do is get a by itself. And so I'm going to add 3 to both sides of this equation. So if I add 3 here and here, right, so these 3's cancel, and so I get 8 is equal to a times 9, a times 9. And so if I take this out over here, I'm just going to divide both sides by 9, and I get 8 over 9 is equal to a. All right. So I have everything. And what I'm going to do is I'm going to look back up towards the top. So I'm going to look at this right here where I had my whole equation. I had this f of x equals to a x plus 1 squared minus 3. And I'm just going to put my value in for a. So I have down here a is equal to 8 over 9. I'm going to plug this in for a. So let's go ahead and leave that up at the top. And so my final equation is this here. F of x is equal to 8 over 9. That's a. X plus 1 squared minus 3. Okay? So this is a quadratic equation in vertex form. So it has the vertex -1, -3, and it has a leading coefficient of 8, 9. So it should pass through the point 2, 5. All right, so what I'm going to do is I'm going to pause the video, and then I'm going to bring up Desmos for us, and I'm going to see if that is in fact true. Does this equation, if I plug this into Desmos, does it have a vertex of -1, -3, and does it pass through the point 2, 5? All right, so we're back here, and I've brought up a Desmos window, and we can see that I've typed in our equation, 8/9 x plus 1 squared minus 3, and I've also put in the point 2, 5. So if I take a look at this, so this point right here, 2, 5, we can see that it does in fact pass through that point 2, 5. And if I look at my graph, if I find -1, so this is 0, this would be -1, and I go down 3, so that would be -1, -3. Looks pretty good that this would be the vertex of my parabola. And so this equation satisfies all the information that I want. It has a vertex of -1, -3, and it does pass through the point 2, 5. And so we can use this same process basically as long as we know the vertex and we know any other point. And so if I highlight my graph here, we can see that in fact it does pass through the point 2, 5, and it does have a vertex of -1, -3. All right, so some of the problems that we're going to see ask us to look at the graph of a parabola and determine the equation. And this process will work just the same. So if I see the graph, what I can do is find the vertex and those coordinates, find any other point that's on the parabola, and just walk through the same process that we just went through. So I hope this video is helpful, and I'll see you next time.